Hi everyone, welcome to the next webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The previous webinars from this training series, as well as the webinars from our Industry Solutions series, are all available on our YouTube channels if you missed those. During this presentation, you'll be able to type your questions along the way, as shown on the screen. At the end, I'll send through your questions to the presenter for his insights. Today's webinar will be presented by Owen Thornton, who has been writing software for 12D Solutions since 2003. Owen has 15 years of professional experience in the civil and mining industries. He's the original author of 12D's Drainage Network Editor and the Drainage Analysis module, and is a 12D specialist in drainage, utilities, plot parameter files, survey conformance, volumetrics, and system setup. Owen has recent consulting experience using 12D model on a variety of large projects. These days, Owen also gives regular 12D training courses in drainage design and macro writing. This presentation is the first in a series we'll be running over the course of 2019. This series of training webinars, Stormwater Drainage Design Fundamentals, covers the basic and intermediate aspects of the three waters modules in 12D Model 14, with special emphasis on the design of stormwater drainage. Over to you, Owen.
Hello everyone, and welcome to this first episode in a series of webinars titled Stormwater Drainage Design Fundamentals. This series of webinars is intended to cover the basic and intermediate aspects of the three waters modules in 12D Model 14. And with a special emphasis on stormwater drainage in particular. The three waters modules covers stormwater drainage, sewer drainage, and also water supply, potentially other things as well. But this series will be presented as a condensed overview of the material we normally cover in the first couple of days of the three waters training courses. Those are training modules W1 to W6. Which we run regularly at 12D Solutions. And this material is often assumed knowledge, prerequisite knowledge for the more advanced training courses, getting into dynamic drainage, hydrograph methods, 2D drainage, and things like that as well. So in this series, the series I imagine is going to go over about half a dozen episodes, and this will be the pilot episode, I guess, so hopefully we don't get axed along the way, but throughout the series we will be creating a construction-ready drainage model with catchments and pits and pipes and culverts and channels and flood extents created from scratch in 3 dimensions and designed for specified minor and major storm events using the rational method. And along the way we'll be producing output plans and long sections and calculation tables as well. So this episode, the pilot, episode 1, project preparation, is really going through some details of the preliminary steps required before the drainage design can begin in earnest. They're not all mandatory, but they can certainly help to make the job easier. So without further ado, let's get into it. So I have a series of steps planned to show in this first episode, and step 1 of 9 steps is to simply create a supertin of the entire finished surface, survey and design. Generally you want a tin that will be linked to your water model so that your water model knows where the finished surface is, and you generally want it to extend further than the extent of just the water strings themselves. You want it to include the full extent of all the catchments that are flowing towards your water strings, and that typically means a super tin or composite tin of your survey and design surfaces. So let's have a look at that in 12D. And here's the project we'll be working on in this series as well. On the left hand side I have a survey, a series of survey models, survey data with a raster image as well. And on the right hand side We've got some design strings as well as a cadastral boundary. Okay, and these have already been provided. We're simply going to merge the two series of surfaces together into supertins. Now typically that's from the tins menu, create supertin, and that would bring up this option. But in fact I've already created them, so I'm going to just go to instead to tins, edit supertin, and I've got a supertin in this job simply called super. And if I open that up, you can see it's just a listing of all of the survey and design tins, and it's not always as complicated as this. Sometimes it's just a single survey tin and a single design tin, but here I've got one survey tin and a whole series of different design tins, and they need to be added in the right order. Normally it's a chronological order, and so the survey is there first, and then depending on how the design has been put together, these are all broken down into different design element components like the lots and easements and drainage, which is this channel here, and the roads, which should be self-explanatory, including curb returns and cul-de-sacs and things like that. There's a tiny little tin there that represents this tiny little traffic island there, that's design traffic. A few driveways on the north here, which are in this driveways, and the basin that we see on the south of this design. And they all need to be done in the right order depending on how the design has been put together. Okay, you can take this a little bit further. This is really all you need for this step, but if I use the little 12D icon here, I can duplicate this panel a couple of times, and I can show you other things you can potentially do with supertins, because I've got a couple of other supertins in here. One is called Super Design and one is called Super Survey Only. In the Super Design one, it's almost exactly the same as the ordinary supertin, except I've simply turned off the survey. So that's just a tin that represents the design only. And on the right hand side here, the Super Survey Only, again it's pretty much the same as the original supertin, except I have set all of the design tins in the special mode holes, which means this survey tin, Super Survey Only, will represent the survey tin only where there is no design. And though these two options also give you some extra things, extra functionality you can do too in terms of producing contours and things like that. But effectively that's all we need to do for the creation of this first step and the creation of supertins. Step 2 then is to create and arrange views for use with the Water Network Editor. Now we're not quite ready to use this Water Network Editor yet, but it is going to be the primary tool we'll be using throughout this whole series. And so it is worthwhile. It might seem like a silly step here and an unnecessary step, but there's a couple of points I'd like to make here. So let's go through this now. You can leave these survey and design views as they are. I personally prefer to create a brand new view for drainage design or stormwater design in particular, and leave the original views that you might have already set up intact. And there's lots of different ways to create views, but if you've already got a view that's nicely set up like this design view, you say, well, I want to create another view with the same properties. You can do it with the gold star if you've got a view favorite for a view like this. But an easier way is just to the left of the gold star, two icons to the left, there is a View Clone button. And I'm going to press this one now, and I'm going to create a, well, it's already created the clone, and it's called it Design Copy. I'm going to come into the name box here and rename it SW for Stormwater. And this will be my view specifically set up for stormwater. Okay, finish there, and I might just drag that over to the left-hand side to cover up my survey view. Okay, and on this view I might just get rid of all the cross sections, but other than that I'll leave it like so. That's looking okay for now. For the section view, and we also want a section view, I might choose to, rather than reuse this long section or cross section view, I might choose to clone this long section view, and again, if you've already set up a grid or whatever you've set up on this section view, it will be cloned as well. So hit the clone button, and I might call this one SW space LS and finish, and I'll just position that over the top of my existing long section view, like so. Just adjust them ever so carefully so I'm not going outside of my workspace. And you might think, well, that's not the way I like things set up. Well, you can arrange them in other ways if you like. The main thing I'm trying to recommend here is that you have both a plan view and a long section view visible at the same time, while still leaving space on one part of your screen, say on the right hand side, for this network editor. Now the network editor is this option here, and it does take up a fair bit of space on your screen, and you want to be able to see all three at the same time. I don't have any water strings to profile yet, so this view is simply set up ready to profile water strings when I create them, and I've got space available so that I can see all three elements at once because they all work together. These plan view, section view, and the network editor. You might also wish to set up a perspective 3D view, and I've got one already set up here. Okay, and I'll talk a bit more about that further on into the series. Step 3 then is to review the survey and geometric design as it pertains to drainage, specifically the surface drainage of the survey and design tins. Now obviously this is going to be your job whether you're using 12D or not. It typically falls into the drainage designer's realm to review the design before you even do any work at all, to make sure that what you've been provided and asked to respond to as a drainage designer is going to work. So I'm merely going to show you a few tools you have available to conduct this review in 12D. So we created the stormwater view earlier, and the general lay of the land there is from north to south here. We have a few different ways of looking at that. In the early stages of a project, it might be worthwhile turning on the flow arrows, for instance, and you can zoom in and see there's a little arrow wherever there's a triangle in your tin, and this is the super tin we're looking at, and to give you the general idea of the fall of the contours there. I'll toggle that off again. There are other tools up your sleeve. From the tins menu, you can go to tins inquire and choose two different options there. There's the height option and the slope option, which you can just leave at the top of your screen, and then wherever you move your mouse over the tin, it's going to report both the Z value and the slope, the total slope of that tin at that point. And that's a good way to just do some quick spot checks and things like that as well. You can leave those two panels up there as long as you like in order to do that. Okay, you could then probably want to move down to your long section view, whether the one of the temporary one I've got here, or the actual road long section. And I've got 1, 2, 3, 4 roads we're proposing. And the roads in a typical job like this is more like a subdivision design. The roads are going to be your main conveyance mechanism for the catchments to run off into, and then we'll be providing drainage within the road network. There's also some significant drainage though off the roads, and in fact it's probably an order of magnitude bigger in this case. So that's one of the first things to realize about or to look for in your job is what's going on outside of where the design is, and is there anything you need to deal with. And as it happens, there is quite a lot to deal with. If I look in the perspective view here, this is including a draped raster over my survey, and we can see the proposed design in the middle there with some contours on it. But if I show you what the survey contours look like, and I've got a series of colored contours here just of the survey only where there's no design, and it's all color coded there from red, or white in fact at the highest points, going through the rainbow colors from red down through blue, and we can see that there's some pretty significant hills in the vicinity there. And in fact, if I zoom around, and version 14, I've got to say the perspective view is much slicker and more responsive than in all previous versions. I'm really loving it. But you can see that on this site these hills are going to have a significant amount of runoff heading towards our site that we need to protect the site from. Okay, so that, and we can see, in fact, if we zoom right in there, that the designers have had the forethought to put in this fairly expansive large cut-off drain with some driveways over the cut-off drain to provide access to existing properties up here in the hills, there and there and there. And then they've done something a little bit unusual and interesting here. The cut-off drain is actually turning a 90-degree bend there just before this driveway, and intended to go under the road and be conveyed through this open drain that runs through the middle of our proposed lots before going under another road there and connecting off into an existing channel that feeds off into an existing basin or dam further downstream. Now, if I look at the survey, that is the blue lines in the survey there are the existing waterways pre-development, and so we are more or less maintaining the existing flow patterns. We're modifying them a little bit, diverting water ever so slightly, but more or less we're maintaining the original flow patterns. And that's an important thing to realize. It also means that this cut-off drain and the open channel and the culverts have seriously separated the stormwater problem into one of primarily transverse drainage, which is all clean water running off the site and into these drains, which will convey away and protect the lots and things like that. But the road drainage is certainly on the downstream end near the basin. That will be separated from this runoff there, and an order of magnitude smaller the flow rates will be on the roads compared with the significant amount of runoff we would expect on this particular site from these hills to the northwest of our site. Okay, so the main road that we have here, where at the bottom, which is I like to start at the bottom here, which I might just spin my perspective view around so that we're looking at things in the same way. And once you've got the contours, a feel for the contours, you can turn those coloured contours off again and just see the raster image. But I've got a series of all my design tins I've set translucent, and my survey tin I've set with a raster. These are all different options you've got with the visualization module as well. I like the translucent tins because it means I'm able to see pits and pipes and things like that and other surfaces underneath. I'll talk a little bit more about that later in the series. But this is this proposed road here is road B, RS2B01, and it's basically just got a sag at the bottom of the hill there, which you can see in the profile there. The other roads are road A, which is this, basically we're redoing this road along the top here. It starts on the right here and goes up the hill to a crest and down the hill to a sag down here somewhere. And there's potentially an option for another culvert there. And then we also have road C, which is this little side road here, and it's got a cul-de-sac at the top with a sag and a crest, and then another sag at the bottom just before the intersection with road B. And so we'll just make a mental note that there's a sag there. And road D, again, there is a sag and a crest up in the cul-de-sac bulb here, or up here if you like. And it basically grades from the crest all the way down to the intersection with road B. So that's what we've got to work with. We're also proposing all of these lots in the middle here, and they're all going to be running off onto the roads, and we'll need to control this drainage. So there's some tools you have at your disposal then for simple tools, and a very, very quick introduction to the tools here. By no means a thorough examination of what's going on, but we'll have some more tools to look at a little bit later that will give us a little bit more detail. So that will do for now. Step 4 in the project preparation then is to set up your workspace for drainage. And this step I've included because I'm showing it in version 14, and version 14 is a little bit different on the water side of things. So we no longer have a drainage menu under the design menu anymore. Previously, everything to do with the three waters was under a drainage menu, and that's considered not general enough anymore, so it now has pride of place on the main menu under the water menu here. And you can bring that water menu up by clicking on where it says water in square brackets. And in fact, a lot of the things that we will need to use in this series will be under the water string menu, and you could pin that one up potentially as well. So I might in fact just leave the water string menu, and look, the water string menu, it's got all the same options as the drainage menu has. Perhaps a few new ones have been added in version 14, but it has been logically, much more logically rearranged. The old drainage menu was getting a little bit old and tired and perhaps a little bit muddled. This new water string menu hopefully will be a lot more logical and easier to find things. It may take a little bit of getting used to though, so I'm presenting it here. As well as the menu, however, we also have the water toolbar, which you can bring up all your toolbars in fact under View Toolbars, and right down the bottom there's a series of water toolbars. The drainage toolbar is no more in version 14, at least shipped with 12D model, and it was getting again a bit too long and unwieldy, and so we've created a whole series of sub toolbars, and this water toolbar is actually a toolbar of sub toolbars. And so we have options for water network options, water string options, drainage, drainage 2D, and outputs. And you can slot that into a convenient spot. Up the top there is good for if you're doing a drainage project or a stormwater design project or any kind of water, a three waters project. It's a good toolbar to know about. And so that's all the setting up the workspace is all about. Of course, you can save your workspace if you want to reuse that. There are tools to do that. But with your views set up and your toolbars and your menu all set up, we can save our project and move on to the next step, which is Step 5, identify crests, sags and overland flow channels. So here we're going a little bit further than we did in Step 3 of the review, and we're actually going to make markers and identify them in our project exactly where all the high points and low points are on our road design, and also pinpoint and identify the overland flow channels, typically your curb and channels, but also the open channels, potentially in the survey as well. And that's, you know, all part and parcel of the same thing in figuring out how the overland flow is going to work in your project. So let's have a look. The first option, you could run it manually through the menu system. If you go to strings, label, chainages, it brings up this option here, but I normally have that panel set up in a chain, and I'll show you that chain now. It's in my customer library here, and it's O2 labels, crests, sags, and this is a simple little chain that's just running two separate commands. The first command is to simply clean out any existing labels, because this chain is set up to be rerun if the road design changes and the crest and sag labels all need to be recalculated because the crest and sags will have moved. Okay, so it'll clean out whatever it was there before, and then run this option here, which is basically that same option I brought up from the menu, but this time the panel's all filled in. Okay, and you can this one is set up to, from the source box here, just identify within the model called design roads, which includes all my roads and cul-de-sacs and curb returns and things, and within that model just the KI strings, which is just the curb inverts. And then in the parameters mode section here, there's a special label mode called crest and sags, which means just identify the crest and sags on these curb invert strings. And at the bottom there's a labels and a marks tab to control where you want your output in. In both cases I'm sending the output to this model stormwater labels crest sags. Both the labels, which have a text style and decimal places, and I've ticked on to label the heights only. And on the marks, it's a 2 meter long marker that's going to cross the strings perpendicularly. So I could run it from the panel here, I suppose, or I could simply go to my recalc menu and hover right on customer library where my chains are for this project, and double click on that O2 labels crests and sags. And I will then have a new model in my project called SW labels crests and sags. And I can zoom in there and see, oh look, that's exactly where my sags are on either side of the road down near the basin there. And I can see there's a couple more sags there on this road C. And there's obviously a corresponding crest on the curb return there to correspond with that sag near the T-junction. And then I've got a another sag showing up here at the top of the road C, where the cul-de-sac is, and a couple of corresponding crests on the curb. So it's often, especially if there's super elevation as well, you'll often find that the crests and sags don't necessarily match the crests and sags on the control lines exactly. And certainly around cul-de-sacs and curb returns that's the case as well. And in fact you can see around this intersection between road B and road D that the road is actually in super elevation. There's a one-way crossfall all the way from this hammerhead all the way down till around about there where the contours start to turn around again. And that's something that we didn't pick up in the first review that is a little bit more obvious now. So there's another sag marker there and so forth. And that chain is set up now so that if the road design changes, we can rerun that as long as the naming conventions haven't changed. We can regenerate these labels, and that's a pretty good guide. Obviously, generally speaking, where you have a sag marker, that's pretty much telling you that you need to place a pit there, and it's giving you a little marker to place that pit. And where you've got the crest markers, it's pretty much telling you where you should not place a pit. More than anything, but it's a little bit more important than that too. You certainly don't want to place them there though. So the next step, as well as just identifying the crests and sags, this one is a related step, and it doesn't necessarily have to be run at this stage either, but to identify all the overland flow channels, which is effectively going to do the same thing. It's going to find your crests and sags for you, but it's also going to form the basis of your overland flow model that you'll link into your water model or your stormwater drainage model as well. So that's an option that's available on the water menu, on the water string menu. Under stormwater tools, there's a downhill strings option. But it's also now available on the water drainage toolbar. This little downhill arrow here, the blue arrow, brings up the downhill strings. And this has changed a lot in version 14 compared with previous versions. And there's a separate webinar on this if you want to go into more detail. I'm just going to run this one very quickly in this series. And in fact, I've got it again saved in a chain. If I bring up the chain, it's 03 downhill strings, and it's a simple option running the option manual because it's a macro. I can preview it to bring up the panel, and it's basically, I'm going to run this a couple of times later on in the course, in the series, but this one is set up on the source box. This one's going to process every design model, so not just the design roads, but all of the basin and the drainage and all of that sort of stuff as well. And within that, it's not just going to label the curb inverts, or process the curb inverts, I should say, on the name mask branch, which is right over on the right-hand side. It's going to do the curb inverts and the DI strings, which are the center lines of all of my open channels and cut-off drains and things like that. As well. And so what the downhill strings does is it basically takes your design strings, and they only need to be super strings with Z values on them, and the downhill strings will identify all the high points and low points, split them all at the crests and sags, and reverse half of them typically, so that they're all pointing downhill. And that's and because we're picking the strings at the centers of all the channels, effectively where all the overland flow is concentrating into channels, we'll have a pretty good model that represents how the overall catchment is shedding off the catchment and concentrating into channels before it reaches any nodes such as inlet pits and culverts and things like that. So when you go ahead and you could run it from here, and this case it's going to take all of those input strings and create a new model called SW bypass and add it with this comma SW to my SW model, SW view, I beg your pardon. So go ahead and run it there, and that's gone and created all of those strings. It's recolored them because I've set the color to be magenta. But there's a representation then of my overland strings. If I just close this panel down, and take off all my design models off the view for a moment. In fact, I'll take off the cadastral boundary as well. You can see that it should have found the crests and sags pretty nicely in most cases. And you'll have nice continuous strings from the crests, from your crest markers, all the way down to the sags in most cases. But it's not perfect yet. It's 90% of the way there to be used as an overland flow model, but there will be some intervention required. So that is step 5, identifying crests and sags. And for the moment, I don't really need that bypass model anymore. I'll just take it back off. We'll use it later on. And I'll add back my design models, which is everything here, maybe except the lots, and get back to where we were. Moving on to step 6 of the project preparation, we want to locate required inlets near intersections and other critical places. So we've already located the crests and sags, which are very critical locations, but there's normally other places on a job that you need to have inlets as well. Typically there's around intersections, on the upstream end of intersections certainly, and possibly other places like near pedestrian crossings or bus bays and things like that. And by the time you've located all the crests and sags and these other critical locations, a lot of the locations of other pits will then naturally fall into place because they'll be dependent on these critical ones first. So get the critical ones out of the way and locate them, and the rest then become a little bit easier, and it's not, you're not starting from scratch, in other words. So there's probably a number of ways to do this, but there is one little tool in the water menu that used to be quite buried in the old drainage menu, but in version 14 it's now quite prominent. Under water string plan edits, right at the top there's this option to place node markers, which brings up this little panel here, place point on string. And I'm going to set this up with my stormwater view as my working view, and it works if I zoom right into an intersection here. In this case, I've already got 2 markers there for the sags where I'm going to have inlets there. But at the upstream side of this T-junction for the road coming, for the water coming down the through road here, I want to have an inlet just upstream of the curb return to control or minimize the amount of water that's entering the T-junction, so that, because if I didn't have an inlet there, it would A, make it difficult for pedestrians who might want to cross at this point, but B, it's not likely to even make it around the corner and make it to that sag, which is what the design intention is. It's more likely to just keep going and flood further down the road there. So definitely need to control the flooded widths around the curb return by placing an inlet there. That's in this case, it's probably the only place where we need to create a critical inlet or locate a critical inlet. There's possibly others around the job as well, but I'll just focus on this one because it is a simple little option, but it's important to get right. So I'm going to use my working view, my string name filter. It could be any one of the strings on the curb really. I'm going to choose the KT, top of curb, primarily because the top of curb string is probably closer than any other string to where I actually want the center of my pit to go. Some people snap onto the lip of curb. I try to get my pits with the pit centers exactly where they're supposed to be built, which might not be actually on any of the strings that we've got there, but the top of curb string in this case is probably as close as any. And I'm going to put these marker points in a model called SW markers, and then with the panel filled in like so and the mode set to from curve or end, it's going to, wherever I snap or pick a point, it's going to snap or drop onto the nearest KT string, top of curb, and then find the nearest curve or end on that string, and then draw me a 1 meter string back from that point, which will give me a good indication of where I need to place my critical inlet, near just on the upstream side of this intersection. Okay, so I simply press the pick point and pick around about there somewhere, and that's just a cursor snap in the middle of nowhere, except, and I get this 1 meter marker string, which is exactly 1 meter away from where the curb return starts. So that is a good location for that critical inlet right there. And that's all I wanted to show in this step. Time to move on to the next one. Step 7 in the project prep is to review and process all other service and utility strings. And again, this is an optional step, but it's a step I recommend. It's often the job of someone else to coordinate crossing services for the benefit of all the other designers on a project. And it's often a very difficult issue because you get data from all sorts of different sources. It could be survey services, it could be surveyed cadastral boundaries even. Sometimes it's not even services and utilities, it's just a boundary string. Basically though, anything that's going to cross your proposed water strings or your road strings or whatever for the and show up on a long section plot, whether it's a road long section or a drainage long section or a sewer long section or whatever. You want to be able to identify all of the other things that cross that and perhaps pre-process them so that you can take this tangled web of data supplied to you and get it into a format that's a lot easier to manage for the benefit of producing all your different long sections that are going to refer to them. Okay, now I have shown this in detail in another webinar which I presented on plot parameter files, but I'll show it again here because it's something I've been recommending as general 12D stuff, and it slots nicely into the preparation steps for stormwater drainage design as well. So I actually have another one of my chains here under my customer library called number 4 create ppf cuts.chain, and if I bring up the chain editor for that, this chain just named create ppf cuts.chain, you can actually find a copy of this yourself. It's installed in the library and there's an example there and also an example map file because this chain refers to a map file to get this process done. But effectively what this step is intended for, and this is just an example, is if I look at my cuts view here, I have this view cuts which is lurking underneath my design view there, and onto that view I've taken, in this case it's a very simplistic idealized case, but I've taken all of the models that are potentially going to cross my proposed water model and will potentially need to show up as a marker in my long sections plot, my stormwater long section plots. So in this case I've got a couple of utility models, sewer and water, on the view, but also the existing and proposed cadastral boundaries if you need to show cadastral boundaries on your long section plots as well. Now some of this information is in 3D and some of it's in 2D, and that's critical to get right. But in practice, in the real world, a lot of the time you get lots of different models from lots of different sources. They're all using different naming conventions and it's a big mess, and the idea is to try and get that into a smaller number of models and control the naming conventions and name the strings based on what the label is that you want to appear on the long section plot. Okay, so we leave this original data untouched, and if I toggle on the string names here, we can see a variety of different string names. The surveys have just got this SVRP, which I don't know about you, but it doesn't mean much to me, but it is a survey code. Okay, but it's not what I want to appear on the long section plot. The sewer strings are all called S something, and the water strings are all called W something, but ideally I'd like it to say sewer or water or something like that. And that's what this chain is intended to do. I'm not going to go into great detail, but it effectively just runs a map file based on whatever data you give it. You set that in the map file and it maps it to new models and new names. So if I hit the run button here, I can actually remove all of this data, and I have instead a series of new models which are just copies. The original data is untouched, but I've got them all into these new models called PPF cuts, 2D, sewer and UT for everything other than drainage and sewer basically. And I now have string codes like RPBDY, registered property boundary. That's starting to look more like something that a regular human like me can understand if I were to see that on a long section plot. And it says water for the water strings, and it says sewer for the sewer strings. And they're all in these manageable models so that all of your plot parameter files can be set up relatively simply the same way, potentially from project to project to project. A lot of time can be wasted in setting up plot parameter files for section plotting because of all of the different cuts, because they're all different from job to job. But this is a method that can be used so that every job has a consistent naming convention for your services and anything that crosses, and we will be able to use that later on in the job. So I'm leaving that there in my model of cuts, and we'll be able to link that into our water model as well and have this information show up nicely the way we want it in a nice manageable way in our long section plots. We are nearing the end of episode 1 here, and we're up to step 8 now in the project preparation steps. And that is a big one. It's actually a very simple step, but it's doing probably more work than anything else in this whole sequence of steps. Read a water model template to create a new water model specifically for drainage design. Okay, and we never really emphasized this much in the past. It's an option that's been around for a long time. But you can predefine your water models for all sorts of different purposes, and it can do a whole lot of work for you. Okay, so at the moment in our project, we don't actually have a water model set up yet. We've got a handful of models on this stormwater view, like stormwater markers and stormwater labels, crests and sags, but we don't have any water strings yet. There's a couple of other ones in there as well that we've created already, but nothing as a water model, which is where our water strings are going to go into, and we're going to set these water strings up in this water model specifically for stormwater drainage. Now, you don't need to do this, but if you don't, you're basically saying you want to set every little detail from scratch, and there's possibly like 200 or 300 details I'm talking about here. It's not trivial, and because this option was a little bit underutilized in the past, in the new water string menu, we've actually made it right at the top there. The first thing to do to create a new water model, and the best way to create a new water model, is to read in what's called a water model template. Now you can run it from the menu, and it brings up this panel, or you can run it from the water toolbar, and it's got its own icon too, a second icon down on the first water network toolbar, I believe it is, and that brings up the same option as well. Either way will work, but we really only need one version of this panel, and it's really very simple. You either read a template to create a model, or once you've got a model set up, you can write your water model out to a template file. And a template file is nothing like a template that you would run along a string to create a road or anything. It is basically just a 12DA file. So I have in my customer library one from a previous job, say, that I've set up as a water model template for stormwater design following the guidelines outlined in the Queensland Urban Drainage Manual, I beg your pardon. So that's why it's called Water Model Template QDM. Okay, and this particular series, in fact, is going to be stormwater design using the rational method following QDM guidelines. Okay, so without going into the details of what's in that file, it is effectively just a 12DA file of a model that has no strings in it. It's just got 200 or 300 model attributes defined inside the file, and they were written out from a previous water model that had all these model attributes preset. And this is going to save us an enormous amount of time now. All I really need to do to create my stormwater model is say I want to create a new stormwater model called SW, and if I want, I can add it to my stormwater view as well with the syntax comma SW, which is also my view name here, and it will add it in. And if I go ahead and hit process now, it doesn't look like anything's happened. So whilst this has just done probably more work than anything I've just been talking about in the last half hour, this little option here, it's really very simple to run. Okay, so what's happened behind the scenes then is that I now have this SW model on my view. Big deal. If I go to models string info table and pick on that SW model, there's nothing in it. So you think, well, what's the point? The point is, under models, utilities, attributes, I can look at the attributes set on this stormwater model, and it's got, let's count them up. It's got at least exactly 200 in fact there, but some of them are in groups as well. There's another whole group of them in this runtime minor and runtime major group. Now that's an awful lot of pre-setting that we no longer have to do, and you can pre-configure water models for different purposes. You could have one for rational method drainage, you could have one for dynamic drainage, you could have one potentially for 2D modeling, you could have one for sewer design, you could have one for water supply, you could have them set up for different customers or clients. So there's all sorts of possibilities, and it is absolutely 100% the fastest way to create a new water model. So that step 8 is a big one. Which brings us to the final step of episode 1, that is step 9. Set sensible water string defaults in project settings from an appropriate drainage.4d file. The drainage.4d file is the setup file used for all of the 3 waters options to define your node types and link types in a water model. And in step 8 we just created our water model via a template, but it was just an empty model. It's now ready to put water strings into, and before you create water strings, it's a good idea to set your string defaults sensibly and make sure you're using the appropriate drainage.4d file as well. Okay, so let's have a look at that now. Now, to set just on the water string menu, just below water model template, which we ran in step 8, immediately below that there is water string defaults. Okay, and that brings up this panel, and we can set all of the necessary defaults we need to, and it's only a handful of them. And we can set them there. We can also actually on the what this is called the quick access toolbar, in fact, which is a new toolbar we've added in version 14. It makes 12D a little more modern looking, I think. But the last icon on there, as well as new project, open project, save project, undo and redo, we've got this project settings icon, which is a new panel in version 14. And this allows you to access in one fell swoop all of the project settings that are stored in the header of your project database. These defaults that are set on this panel are only one little part of the overall project header in your database, and in fact they're all available under here as well. Under water string you can see pretty much the same information. So you've got a choice now. You can either go to this panel from the water toolbar to bring up the water services defaults panel, or you can just click on project settings here and come down to water string and set them all this way. The choice is yours effectively. But here is where you typically want to say, well, what default finished surface tin do you want to link to each one of your water strings? And here I would typically, as it already is set the supertin that we created back in step 1 as the default finished surface tin for all my water strings. Then I've got details on nodes and links. Now there are subsections here for property controls and house connections, and they're related to sewer design, not to stormwater drainage, so I really can limit myself just to these settings here. And most importantly, it's actually the node type and the link type to get right, because a lot of the time the node types and link types are predefined in the drainage.4d file with appropriate properties to define their size and thickness and all of that sort of thing. So settings on the diameter, for instance, of a node aren't that important. Other things like the minimum grade and minimum cover and the drop through the nodes, whilst you can set them as defaults, they can be overwritten via when we start using the network editor in a perhaps more simple way as well. So it's mainly just the node types and the link types. And if we look at the list here, that is not the standard list you'll get from 12D if you just run 12D out of the box. This is actually a different drainage.4d file that has been installed alongside the standard one in the setups folder. So I'll just take a moment to explain all of this, but another new toolbar we have in version 14 is this Explore toolbar. There is an older one called the Explorer toolbar, but this one's a little slicker looking, and it's perhaps a little bit more straightforward. So we've got options to open up Windows Explorer windows for just exploring the working folder of the project, or the customer folders, or the user folders, or the so-called 12D folders, which are installed with 12D, and we certainly don't recommend you edit them, but there's a lot of good files installed in there. Now, holding that icon down, you can access at each one of these levels the setups folder or the library folder. Okay, and in this case it's a 4D file, and it's actually in the setups folder, and that's where 12D installs its files. If I open that up, it opens up a Windows Explorer icon, and this is where 12D installs the setup files. And if you sort them by type and scroll down, you can see there's a range of different drainage.4D files there, okay, installed with 12D. But it's in fact this one that's just called drainage.4D that is the default. Okay, but if you're, in this case, in this series, I'm presenting this design based on the QDM guidelines, the Queensland Urban Drainage Manual, and I would like to instead use this one, Drainage BCC, which uses the pit types that are widely used in Queensland, that are based on the Brisbane City Council drawing set, also very similar to they're all the same pits that are used by TMR and specified in the IPW EAQ drawing set as well. But they're all published by Brisbane City Council along with the inlet capacity curve, so that's why they get the moniker BCC there. But they are widely applicable throughout all of the state of Queensland. So what you can do, for instance, is copy this file into a different folder higher up in your search path. So if I just close this one down, I could copy it to my user folder or my customer user folder. And if I open up my customer user folder, you can see I've already in fact done that. I took that drainage BCC file out of the setups folder and I copied it into this custom folder, which is my customer user folder, and I've renamed it to just drainage.4D. And that means that when the project starts up, 12D will find this drainage.4D file before it finds any other, assuming you don't have one in your working folder. Okay, and in fact, we're getting a bit ahead of ourselves here, but if I were to show you the new drainage.4D editor, you can see here that I can tell that 12D's found the drainage.4D in the customer user folder because it says edit there rather than create. It's found one in the setups folder as well, but I can't edit it there. It's a read-only folder, that setups folder that's installed with 12D. Okay, so that's how I've set up, and very simply, just by copying the BCC file from setups into customer user and renaming it to just drainage.4D. If you've got your own drainage.4D, you can do a similar process there. Just have it somewhere higher in the search path hierarchy than the setups folder, and then you won't be using the ones installed with 12D. Okay, so simple as that. In this case though, I've got a series of different pits, and to people who aren't familiar with them, it probably does look rather baffling, but just to break it down in a nutshell, all the pits that begin with type letter A there are the standard type A gully. It's a rectangular pit inlet that's 900 and something by 800 and something millimeters in dimensions, and they're all the on-grade inlets. Skipping over this strange one, EB2, I'll move over to all the pits that begin with S, and they're all the sag configurations, and the ones that are SA are sags of the type A gully, and that's type A gully using the Brisbane City Council terminology. Okay, moving further down, we've got a series of different manholes. We've also got a couple of sag field inlets there. We've got a series of manholes of different sizes there, including the extended manholes that get used in Queensland. And we've got further down, we've got a series of different kinds of head walls and channels and bypass nodes and basins and tanks and orifices and weirs and stuff like that. Not all of these are necessarily going to be used in every job, and things like the tanks and the basins and the orifices and weirs are probably more likely to be used in a hydrograph method rather than a rational method design. But they're all there, and it's the same file whichever kind of design you happen to be planning for. Okay. In the case of all of these type A gullies, the second character begins with an L or a K. That stands for lip inline or curb inline configuration. And the reason we have to discriminate here is because they have different set-out points and different inlet capacities, and potentially different symbols as well if you're talking about plotting. The third character is a 2, 3 or 4. That's the size of the lintel, the 2.4, 3.6 or 4.8 metre long lintel. Again, straight off the standard drawing set from Brisbane City Council. It's your small, medium and large lintel. And again, different lintels have different inlet capacities. The last character in the set is a D or an E, and that is, again, Brisbane City Council terminology. Type D is a mountable style curb and gutter, and a type E is a barrier curb curb and gutter. Okay, so D is mountable, E is barrier. And again, the two can have different inlet capacities. So that's why there's so many different type A gullies in the file here, because there's lots of different ways to configure them. In truth, it is the lip inline that is preferred, but a lot of the times you need to use curb inline to retrofit an existing system or something like that, or upgrade an existing system. It still has to be curb inline. The curb inline, the grate sticks out into the roadway more and causes a cycling hazard more than the lip inline does. And it also has less inlet capacity than the lip inline. So the lip inline tends to be preferred these days in Queensland. And through most of this job, without checking, I can tell you that we have a barrier curb throughout most of our roads. So if we're trying to pick a good default here to set in the project settings, I would probably pick a lip inline with a type E, and it just so happens that in the part of the design that I'm going to start creating strings in is this area here, and it's a little bit unusual, but I have more sags in this part of the road than I have potential locations for on-grade pits. So whilst I'd normally recommend an on-grade pit as a default, a good default to get us started here would probably be one of these sags here from the SA series. SAL for lip inline. I'd always go with the smallest lintel, so SAL2, and I've got barrier curb. So the best default here is probably an SAL2E. So I'll select that. I'm not going to worry about changing the diameter or the drop. That's going to sort itself out later on. And the name is also going to get allocated. Every node is going to be given a default name of X until we rename them. So that's fine as it is. And again, I've chosen this default merely because for the strings I'm about to create in my water model, that is going to be the most common node type. Okay. So you want to pick the most common one, so there's less to change later on. Because when we go and create a drainage strings, they'll all have this node type. Likewise for the links then, or otherwise known as the pipes. A typical minimum pipe size in Queensland, according to QDM guidelines, is 375 mil. So I type in 0.375 because it's in base units. Minimum grade, 1 in 200 there, or 0.5%. This is the only place, in fact, in the Three Waters suite where you'll specify an input grade as 1 in. Everywhere else it's percent, but this is one of the older settings in the Three Waters suite there, and it's so 1 in 200 is a good minimum grade default for stormwater drainage. And the minimum cover I've set to 0.6. Now again, that is straight out of the QDM guidelines. It is going to depend on how thick your pavement is, but if I look at the pavement on this job, I've got a model in here called Mesh Roads. These are all the tri-meshes as part of the road design, and it's roughly 0.5 metre deep, so that 600 mil cover is actually going to work nicely to keep my pipes just below the bottom of pavement there. Okay, but I'm probably not going to use PVC pipes. For the pipe or link types, I should say. These numerical types that are again from our BCC drainage.4d file, they're also in the default drainage.4d file, the generic one. But these ones are straight out of the Humes catalogue, the rubber ring joint concrete pipes. And you can choose as a default whichever is most appropriate for your job. A lot of people use class 3 where they cross the roads and class 2 under the footpaths. Other people I've been hearing recently are just specifying class 4s all over their job, regardless of where the pipe is, and saying that that's adequate. And from the contractor's point of view, it's nice and simple for them. They've only got one type to worry about. It's also easier for the design. So I might just follow that lead and keep it simple for today and say these are my defaults. Okay, all you need to do is hit the set button, and those details are set. And now whenever we create drainage strings, or I beg your pardon, whenever we create water strings, they will be created with these node type and link types already set. Okay, now we can finish this panel and come back to it at any time and change it. It's remembered our settings, or we could do it from the water string defaults option here. Okay, the choice is yours. But now we have done all of the 9 steps I was planning in this project preparation episode. Ready now, our project is now ready for us to actually start creating water strings for the first time. And that's what we can expect next time in episode 2. So, thank you very much for watching. I hope you've enjoyed this, I guess, the first episode, or the pilot episode of this series, Stormwater Drainage Design Fundamentals. I'd like to now open the webinar up to any questions we may have had while you've been listening, and hopefully I will have some answers for you.
Thanks for that, Owen. We're quite close to time today, so I think I might just email you these questions for you to get back to everyone afterwards. Thanks, Owen. The recording of this webinar will be available in coming days through our website and our YouTube channel. We've got some more exciting webinar topics coming up in 2019, so keep an eye on our emails and social media for details. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.